Electronic basics: voltage and current. Voltage and current. Voltage is the difference in electrical potential between 2 points in space. It is a measure of the amount of energy gained or lost by moving a unit of positive charge from one point to another, as shown in Figure 1.1. Voltage is measured in units of joules per coulomb, known as a volt, V. It is important to remember that voltage is not an absolute quantity, rather, it is always considered as a relative value between 2 points. In an electronic circuit, the electromagnetic problem of voltages at arbitrary points in space is typically simplified to voltages between nodes of circuit components such as resistors, capacitors, and transistors. Figure 1.1. Voltage V1 is the electrical potential gained by moving charge Q1 in an electric field. When multiple components are connected in parallel, the voltage drop is the same across all components. When multiple components are connected in series, the total voltage is the sum of the voltages across each component. These two statements can be generalized as Kirchhoffs voltage law, KVL, which states that the sum of voltages around any closed loop, for example starting at one node, and ending at the same node, is zero, as shown in Figure 1.2. Figure 1.2, Kirchhoffs voltage law, the sum of the voltages around any loop is zero. Electric current is the rate at which electric charge flows through a given area. Current is measured in the unit of coulombs per second, which is known as an ampere. In an electronic circuit, the electromagnetic problem of currents is typically simplified as a current flowing through particular circuit components. When multiple components are connected in series, each component must carry the same current. When multiple components are connected in parallel, the total current is the sum of the currents flowing through each individual component. These statements are generalized as Kirchhoffs current law, KCL, which states that the sum of currents entering and exiting a node must be zero, as shown in Figure 1.4. Figure 1.4, Kirchhoffs current law, the sum of the currents going into a node is zero. An intuitive way to understand the behavior of voltage and current in electronic circuits is to use hydrodynamic systems as an analog. In this system, voltage is represented by gravitational potential or height of the fluid column, and current is represented by the fluid flow rate. Diagrams of these concepts are shown in Figure 1.5 through 1.7.
Thank you.